And we're back. Your favorite thing happened here today. And the favorite thing that happened was it froze on me. So I got to get tech support back in. But eventually, we are going to get this working. I promise. Okay, there we go. So where we left off, we were doing long division. And we took x plus 3 here, and we multiplied it with x squared. And so when we multiplied that through, we got x cubed. And then 3 times x is 3x squared. And that's what we were trying to get. We're trying to get the x cubes to match up before we change the signs. So we change. Maybe we should stop doing that because maybe that's causing it to crash. I don't know. What do you think? I don't know. Okay, so those will cancel out, leaving us with a negative 3x squared. And then we're going to bring down the x now, finally. Almost there. Bring down that plus x. Good. So then how does x become a negative 3x squared? Well, we multiply it by a negative 3, so that becomes negative 3x. Oh, we need to be an x squared, so we multiply it by a negative 3x. Not just by a negative 3, but a negative 3x. And the reason why is because x times negative 3x is a negative 3x squared, and we get that to match up. There we go. And then 3 times negative 3x is a negative 9x. Cool. And then we change the signs. And then those become pluses or Chinese stars. And so then the 3x's, negative 3x squared and positive 3x squared will cancel out. And then we have 9x plus 1x is 10x. Okay, last but not least, we'll bring down that negative 12. Last but not least. Okay. And then we're going to take x, and how does x become a 10x? Well, we multiply it with the 10. So x times 10x is 10x. And then 3 times 10 is actually 30. There we go. Whoa, this problem rings a bell. I think I remember this problem, actually. So then we change the signs. And so we get a remainder of, the 10x's go away, we get a remainder of negative 42. Negative 42 is what we get a remainder of. So the final answer then for this problem is 2x cubed. So 2x cubed plus x squared minus 3x plus 10. And then we have our remainder, which is negative 42 over the divisor, which is x plus 3 that we got from right there. And so that's our answer. And because of the remainder, we say no, not a factor, not a factor. Now, that was using long division. I highly recommend you use synthetic division. And so just to show you why, we're actually going to go ahead and erase that there. Hopefully you got that answer. Did you get it? Memorize it with the remainder negative 42. Now watch how fast synthetic division is. You saw that work we did? Watch how synthetic division works. So don't use positive 3 because we set it equal to 0, and so we get a negative 3. So we just put down the negative 3, and then we bring down, don't forget our placeholder this time. So we get negative 3, and then we bring down the 2, the 7, missing a 0x squared. So bring down the 0, the 1, the negative 12. Watch how fast this goes. Bring down the 2, negative 3 times 2 is, negative 3 times 2 is a negative 6. 7 minus 6 is 1. Negative 3 times 1 is negative 3. Negative 3 and 0 is a negative 3. Negative 3 times negative 3 is a positive 9. 9 plus 1 is 10. Negative 3 times 10 is a negative 30. Wow, look at our remainder, negative 42. How fast was that, you guys? So then starting with 1 power less, so not x to the 4th, we're going to go x to the 3rd, 1 power less. Our final answer, is this what you got on the long division we just did? 2x cubed plus 1x squared minus 3x plus 10 with a remainder of negative 42 over the divisor, x plus 3. What? And no, it's not a factor. Bam! So get used to doing synthetic division because it's definitely a lot faster and a lot easier. So then jumping down here to number 13, lots of placeholders for number 13. So set it equal to 0, add 1 to both sides. So we get p is equal to a positive 1, what we're going to use for synthetic division, my favorite. And then we're missing a 0p what? Squared, and a 0p to the first power, and then we have our negative 1 there. So we're going to bring down the positive 1 from the p cubed, then bring down a 0, then bring down the other 0 from 0p to the first power as a placeholder, and then bring down the negative 1 at the end there. Okay, so then all you have to do is bring down the 1. 1 times 1 is 1, and then 1 plus 0 is 1. 1 times 1 is 1. 1 plus 0 is 1. 1 times 1 is 1. Negative 1 and positive 1 is a 0. Remainder is 0. So we had p cubed, but we're going to do 1 power less than that. So 3 minus 1, 1 power less than that is p squared. So we're going to do 1p squared plus 1p plus 1 with remainder 0. And yes, it is a factor. So that's our answer for number 13. Is that what you got? I hope it is. Okay, so there's a synthetic and long division. Number 14 is deciding on even, odd, or neither. And so then, let's see here. Oh, shout out. Yeah, that teacher, she's famous. This is cool. So appreciate you guys reminding me of her to help us remember neither. Let's see here. So everywhere we see an x to find if it's odd, even, or neither. So this is a function now, not a degree. This is different. Yeah, degree would be something completely different. So not degree. All right, excellent. Thanks for taking my trash out. Yeah, I'm just here alone after school doing a video for my students. Woo! Yeah, because I love you guys. Yeah. Thanks for watching. Okay, so everywhere we see an x, we're going to plug in a negative x. So there we go. So we have negative 3, and then everywhere we see an x, we're in parentheses, else you get it wrong, put a negative x, plus negative x all squared, plus 2. Excellent. And there we go. And then what we're going to do is we're going to go ahead and simplify that and see what we get. And so this is the same as negative x times negative x times negative x is what we're multiplying there. And so negative times negative is a positive times a negative is a negative. X times x times x is x cubed. So that negative is what that becomes. Then put that in parentheses still. We have to bring down the negative 3 now. Whoa. So now we have negative times a negative is a positive 3x cubed. And then, there we go. Now negative x squared is just going to be negative x times negative x, which is a positive x squared. So we'll bring that down, positive x squared, and then just plus the 2. Okay, so now we need to look at the signs and see if it's even, odd, or neither. So if it's even, it'll look exactly like the original equation. It'll be negative, positive, positive. And oh, it's positive, positive, positive. So it can't be even. So we take even off the list there. Oh, but it could be odd. And how it's odd is if all the signs changed. So, oh yeah, because look, the first one changed, right? Negative 3x cubed, and then, oh, positive 3x cubed. So that's a change in the sign. So that's a good thing. Oh, but then if we look at the positive, positive, and the positive, positive, stayed the same. Now it can't be odd, because odd has to be that they're all changed. And so that means it's not changed. Some are changed, some are stayed the same, so that means it's neither. So the answer to number 14 is neither. The answer to number 15, let's see. So we're going to plug in, again, a negative x everywhere you see an x. And then, negative to any odd power is just going to be negative back again. So it will be 12 times negative x to the 5th when we multiply that through, minus x. Put the negative out in front. So we get a negative 12x to the 5th minus x. Now we look at the original signs. It was positive, positive, but it became negative, negative. That means that this function is indeed odd. Woo! Odd function. So not degree now. That's something different. That's something different. Odd function. Excellent. Last but not least, number 16. So can you guess which is this one's going to be? So we have negative 5. We're going to put a negative x all squared plus 4. Negative x times negative x is a positive x squared. Bring down the negative 5. Bring down the positive 4. So, oh, look at that. It looks like itself. So that means it is even if it looks exactly like itself. Bam! All right, excellent. So far so good. We're going to press the limits here to see if we get an error or not. Hopefully not, but we want to push the limits. So that's what the tech support guy told me. Okay? So you can fast forward if you need to there. But here we go. Number 17 now. For each graph, state whether it represents an odd degree function or an even degree function. State the number of real zeros. Describe the end behavior. Okay, so first of all, let's see here. Odd or even? Degree now. Degree. Let's see which one it is. Okay, so to figure that one out, we come to the graph. And we see visually it does go through the origin, so it might be odd. Might be even. If it was even, it would actually mirror the image. So it would actually look like that. Yeah, so that right there is an even function. So since it doesn't do that, it's not going to be even. Oh, there's another option. It could be neither, right? Yeah, I forgot about that. It could be odd or neither is what the options we have left. So now if it's odd, you can rotate it 180 degrees and it'll look like itself. Ready? Rotate it around the, rotate it around the origin. Bam! Yeah, it looks like itself, right? That's cool. So that means that this one is an odd function. Odd, oh, but it's not talking about odd function, Mr. Newbold. Now I'm glad I brought this up because this is something different now. I just showed you that it's an odd function. I just showed you that it's an odd function. Now it may or may not be. It's an odd function. I know it is, and that's not what we asked for, Mr. Newbold. That's for degree. So we don't want this one. But that's how you find an odd function visually. It's actually asking for the degree now. Oh, for the degree? Well, the degree is the power. So basically, is this x cubed or is this x squared? Yeah. So it's asking, is it odd or is it an even power for the leading coefficient? For the leading, well, not for the leading coefficient, for the degree. Yeah. So, well, you take a look at the graph, and you try to see what that looks like. Well, I mean, it's kind of expanded and stretched a little bit there, but it does look like x cubed, doesn't it? So I am going to say that this is an odd degree function. Now we'll go ahead and prove it to you that this is odd. Oh, it's also odd degree function. Oh, don't say function, Mr. Newbold. Odd degree polynomial. So we're going to say this is an odd, because they're two separate things. Don't get confused. Two separate things. So odd degree polynomial. Cool. All right, so then we'll go to the graphing calculator. Oh, I'm going to guess. Now, I'm not probably going to get it, but I'm thinking, let's see, x cubed. Looks like it expands by, I'm going to take a guess here. Looks like it goes up about too high. So I might be wrong. This is just a guess. It doesn't really matter as far as it is x cubed, I think. So let's see here. It looks like it froze on us already. Possibly. Is it still working? Huh. Oh, good. Our video is still working. It's just our calculator that's crashed. Wow. Good job, calculator. Any event? Wow. So I'm going to pause it for a second, and then we'll come back and finish this problem. Thanks for your patience there. All right, thanks for your patience there. So, yeah, I had to reset my calculator. Yeah, technology. Wow. Okay, so 2x cubed. And we're going to leave it at that and see if this is looks like our equation. Ooh, it looks pretty good, pretty good. Doesn't go up and down as much, but that's okay. So, yeah, so it goes up and then carries on up again. So because it has the end behavior of going to the left is going to be negative infinity, going to the right is positive infinity, and then our graph going to the right is positive infinity, our graph here going to the left negative infinity. That's going to mean odd. This is going to be an odd degree polynomial. Not a function, but an odd degree polynomial is what we're talking about right there, right here, right now. Okay, excellent. So then, there we go. So that's that one done. State the number of real zeros. Oh, cool. 1, 2, 3. Yeah, there's 3 zeros. Nailed it. It doesn't ask for them, but could you label it? Yeah, well, we got a 0, -3, and we have a 0 at 0, and we have another x-intercept, is another word for 0, at +3. Cool. Okay, so 3 zeros. And then describe the end behavior of the graph. Oh, we already did, but let's write it out. So as x goes to the left, -infinity, y goes to the -infinity, right? So as x, the numbers of x go negative, -1, -5, -8. As the x values go to the left, y values go down to -infinity. So we'll put -infinity there. As x goes to the right, you're not done yet for end behavior. You've got to put all this down. As x goes to the right, what does y do? So then y goes to +infinity, upwards. Cool. So there's your answer for number 17. Making this video kind of long to stretch the limits because that's what the tech support guy told me to do. Yeah, go Sammy, shout out. So this one, let's see here. So this one reminds me of x squared or maybe x to the 4th. And so that's an even degree polynomial. Even degree polynomial. Even degree poly. Cool. So then that's one done. Then it says how many zeros does it have? So 1, 2, 3, 4. So we have 4 zeros as our answer there. And then it asks for the end behavior. And so the end behavior is +infinity and +infinity. I drew that graph for you. Did I do an okay job? Yeah, I used the paint program. So as x goes to the left, -infinity. Y goes to the right, +infinity. As x goes to the right, +infinity. Y goes to upwards, +infinity. Okay, so it goes to the left, upwards, goes to the right, x goes to the right, y goes upwards, +infinity. Cool, so there's that one done. Nailed it. Okay, so for this problem, I think we called it B on your paper, or A, I can't remember which one it is, but either way, problem number 18, the two problems that go with 18. So you have a third, x cubed minus 5x plus 2. So basically, wherever we see wherever we see an x, we're going to plug in a 2. So plug it in there and there. And so here we go. So P of 2 is equal to 2 cubed minus 5 times 2 plus 2. And so 2 cubed is 8 minus 10 plus 2. And so that's going to be 8 minus 10 plus 2 is 10 minus 10, which is 0. And if we wanted to go the extra mile, we'd say yes, it's a factor, because whenever you get 0, you found the factor, or the zeros. Remember the zeros, the x-intercepts? So yeah, x equals 2 is, yes, a factor. Or x plus 2, yeah, x plus 2. X minus 2, sorry. Okay, so then over here, part C, we're going to plug in a -1. So P of -1. And so everywhere we see an x, we're going to plug in a -1 there. So then -1 times -1 times -1 is a -1. Plus 5. And then a plus 2. So that's going to be a 7 minus 1 is 6. So there's your answers there for number 18. Talking about the relative maximum, minimum. Find all zeros rounded to 3 decimal places. Ooh, that's interesting. Okay, so that means they want us to use our calculator, it sounds like, huh? Okay, so here's the equation. Find the relative maximum and minimum. So the maximum is the hill. I know you're saying +infinity or -infinity is the maximum, +infinity, but we're talking about the relative, right? Relatively close to the graph. So relative. So it's just like a smaller maximum and a smaller minimum is what we're looking for. Where the graph changes. So I'm looking here, it's hard to guesstimate. Looks like at -5, but it could be Not exactly there. So why don't we use our calculator, because that's what it really wants us to do. So we're going to go to our calculator there. We go to y equals. We're going to type in, let's see here, so x squared, is it? Whoa, what the devil? That's supposed to be a third? I hope it is. I don't know what happened. Why does that say x squared? So x cubed minus 2x squared minus 5x plus 6. We'll just graph it and see if it looks like it or not. Yeah, kind of. Let's see. Our window range, yeah, it looks kind of like it. Let's see here. So I'm pretty sure it's not to the fourth. Yeah, so why don't we adjust our window range? It looks like -3 to 3 is what they have on our window there, and then -10 to +10. So why don't we change our window to make it match on the graph there? So the x value is -3 to 3. There we go. Let's see if that looks, yeah, that looks more like it, doesn't it? Cool. So to find our maximum, we're going to use the trace button. Ooh, 0, 6 is where it, yeah, 0, 6 is the y-intercept there. That looks like that matches. So we're going to trace upwards. There we go, trace upwards. So then let's see, right about 8.15 for the y value, 8.20, 8.20. Yeah, so right about there is where our maximum is. But just to make sure, we're going to use our maximum function on the calculator. So second calc, maximum, there we go. So it's asking for a left bound. So we're going to go left bound. So go a little bit to the left, push enter. Go a little bit to the right now of the maximum. Go to the right, push enter. And then make a guess. It's asking for a third point. So guess right about there. Okay, so our maximum is -0.786. Wow. And then y equals 8.2. So we'll put that here, and we'll write it down. Our relative maximum point is -0.786. It says round. Maybe we could also round these ones as well. So -0.786, comma 8.209. 8.209 if we're rounding to 3 decimal places. Cool. So that's our maximum. Yeah, very beautiful maximum. And then let's see what our minimum is. So we'll go to trace. And so this time for our minimum, yeah, let's do second calc again. Oh, look, number 3. It says minimum. So we'll hit minimum. There we go. So we're going to scroll to the right. It's asking for a left bound from that minimum. So right now, I'm right there about at the minimum. So if I go a little bit to the left of the minimum and push enter, and then it wants the right bound. So go a little bit to the right, push enter. You can see, see these arrows? You see these arrows right here? That's your left bound and right bound that you just did. And you might have arrows or maybe not. Now it's saying guess, and I'm going to guess right about there. Okay, so then our minimum is -2.119 and -4.06. So we'll write that down here. So that's going to be, positive 2.11. Well, 96 rounds up to maybe 1, 2. So if we're trying to round to the nearest thousandths or 3 decimal, tens, hundreds, thousandths place, that 6 would make that 9 go up to the next one and make it 2. So 2.12 really. Comma, and the -4.061. -4.06 or 0.061, either way there. And so that's our minimum. Now find all the zeros. Wow, this is very calculator intensive, isn't it? So to find the zeros here, looks like right at 3 is what I'm thinking. Oh, you can eyeball those zeros. So why did it say round to the nearest? I don't know. We'll see. Okay, so let's see here. We'll go to the zeros. In fact, to help you there, I'm thinking, oh good, the calculator did it. Look at that. So x equals 3. That's one of my zeros. So x equals 3. And then what else does x equal? So we'll push trace. If you're not sure, you can actually go to second graph or second table. And so we can see another 0 using the table. At -2, at 1, and at 3. Everywhere y equals 0 is there zeros. So it's the x-intercept, so where it crosses the x-axis. Again, that's at, let's see here, so negative 2 and 1 and 3. So negative 2, we already got 3, and so x equals 1. Let's verify that. Yep, 1, 0. So right there is what I mean for our zeros. You see that? Also, I had down below, I had a positive 3, 0 as well. Cool. So there's your zeros for number 19. Wow, this video is definitely not long enough. It's past the test, I think. We might have fixed it. Maybe, I hope you turn your speaker down. I talk a bit too loud, huh? Sorry about that. Sorry. So let's see here. So we're going to go ahead and stop the video now, and we'll finish the last few problems on the last video. So thanks for watching, and we'll finish on one more video. Peace out. Yeah, yo, thanks for watching.